Good afternoon, everyone. This is Sir Albert, and it's really good to see your beaming faces. I think you're all excited for today's math challenge. For today, we're going to solve a math problem, and I hope it's something that you will find exciting. Okay, so is everyone ready? Give me a thumbs up if everyone's ready. Thumbs up, thumbs up. Okay, we're good. Let me share my screen to you now. Okay.
Sir, this
Are we good? Are we good?
yeah, it's there now.
Okay. So everyone can see my screen now. So as I was saying, today's problem solving is about thinking patterns. And these are our objectives for today. First, we'll make use of the problem solving technique of finding patterns. And then understand the importance of patterns in solving real life problems. And finally, my biggest objective here is for you to be able to appreciate the beauty of math. Okay? So here's what we're going to do for today. I'm going to show to you a certain math problem which I'd like you to solve on a piece of paper. Take note that you are not allowed to use a calculator for this problem. Okay? Ready? So here then is the problem that I'd like you to solve. This is a problem that I took from one of the competitions that I have participated in. So it was taken from the Signayan 2009 competition. And this one is actually a difficult problem for a number of people. And what really made this difficult is that during the competition, they were simply asked to solve this one in 1 minute. In your case, though, I'm going to give you about 6 minutes to be able to answer this question. Okay? So prepare your scratch paper and your pen. And here's the problem. I'd like you to find the value of this expression. Okay, so I hope everyone can see the expression. It is the square root of 48 times 49 times 50 times 51 plus 1. No one is allowed to use a calculator. And you have about 6 minutes to finish this task. Try to make your solutions complete and organized, because later on I'll be asking for some volunteers to discuss their solution. I hope the problem is clear with everyone. Let me know if there are concerns about this problem. No, don't send your answers, Aldrich. Just keep it. And after 6 minutes, we're going to discuss your answer or your solution to this answer, or your solution to this question. Okay, that's good, Aldrich. You're already done with the answer. That's good. The others don't feel pressured if you still don't have the answer or you think you are still far from getting the correct answer. You know that for this one, what really matters for me is your approach to finding the answer to this problem. If you won't be able to give me the answer in 6 minutes, that's fine. And I'm actually curious how Aldrich got it very fast. Again, take note, no calculators. Okay, everyone? No calculators. Last 2 minutes, everyone. 2 more minutes. Last 10 counts, everyone. Again, if you don't have the final answer, that's fine. Just make sure that you will be able to discuss more or less the approach that you try to use to be able to solve this problem. That is what's more important for me here. What was your approach to try to find the correct answer to this? Last 10 counts, 10, 9, 8, 7, 6, 5. Let me stop sharing my screen now. 4, 3, 2, 1. Okay, stop working, everyone. Okay, how was it, right? Let me know who among you has a final answer. Raise your hand. We only have Aldrich, I also have EJ, and I also have Kia. Okay? I'm interested first with those who have final answers. Let's start with Aldrich. Can you unmute yourself? What's your final answer?
70.
70. Okay? What about EJ? What's your final answer? Are you still solving, EJ? One more solving.
1081.
1081. Gian, you also have a final answer, right? What's your final answer?
Square root of 2,400.
Square root of 2000,
Square root of 2,402.
2402. Okay, so let's see if any of those answers are correct, right? Now let's see first. What about the others? Okay, the others who did not get to the final answer. I'm interested what method or at least what did you try doing to be able to get the correct answer? Anyone? What? Or were you just simply surprised and you were shocked at what the problem was all about? Okay? Let's see. Zoe. What did you try doing, Zoe?
It's the multiply the numbers and then add the one that divided by 5.
What did you do? Ah, okay. Okay. You were trying to divide by 2, but actually what you were being asked is to get its square root. So what you tried doing was to multiply all those numbers, 48, 49, 50, 51, and then add 1. But you're not supposed to divide by 2, rather, you're supposed to get the square root of that one. And of course, when you do that, you end up with a very big number, right? Okay? And I guess that's the part wherein it took you a long time to be able to do that one. Okay? Let me hear, Kito, what did you try doing?
I basically tried doing the same with those.
Multiply everything?
But I was still not dividing and taking a bit longer.
Really? It was taking you long because you're working with big numbers.
Yes, and I got overwhelmed by the question.
It's not ask you to just do it in just 6 minutes. Okay? For those have final answers, let me see what you tried to do. Gia, what did you try doing?
So for each number, since the number equals to 49, I estimated their square root, which is 7. So 7 to the power of 4 is 2,401, and I add the 1. So the second follows on 2,402. But since there's no exact number for the square root, I just left it as square root of 2,402.
Okay, that's very interesting. You're working with 48 times 49 times 50 times 51. So what you tried doing was to estimate everything on 49 by doing 7 squared. And then 48 estimated somewhere at 49 as well. Okay, that's a good idea. Aldrich, can I hear from you? What did you try doing here? You were fast. Please unmute, Aldrich.
Well, okay, so I multiplied them in groups, so it's like I did like 49 plus 49 times 51, that is like 2,499 if I did it correctly, and then the other one 48 times 50 is 2,2400, but I forgot to multiply them.
Oh, you forgot to multiply the 2,000 plus with the other 2,000 plus.
Yeah.
But you also have to do plus 1 and then get the square. Okay?
Yeah. Yeah.
Okay. Let's see. Oh, yes, Carlo.
Well, sir, I was stuck at multiplying them and then the time was ending. And then while you were asking yours, I was thinking of another solution, but I still haven't finished that solution.
Tell me, what's the idea behind your next solution?
It's like 48 plus 40. It's like I get the average of 48, 49, 50, and 51. And since it's no average, I just like mysteriously make it to 49 and 50. And since there's a plus 1, I just add 1 to 49.
Okay, that would actually make sense, get the average of something, but more or less that would just give you a close estimate of the actual value. But at least that's going to be a good approach when you have to deal with very large numbers. Okay, now let's take a look at the solution to this one. So let me present my screen. So I hope you can see my screen. I'm showing to you my whiteboard. And we are asked to find the value of 48 times 49 times 50 times 51 plus 1. And as you have all realized, this is a very big number, and it's going to consume a lot of time if you're going to multiply everything and then add 1 and then get the square root. That, of course, is going to be the straightforward solution to this one. Some of you employ estimation, and I think that's also a very good technique here. But if you would remember my title for this one, this is really about pattern making. You see, when you are faced with a seemingly complex number such as this, it's complex because the numbers are too big. What we can do is maybe we can try to understand things here by trying to work with patterns. Okay? If you think about it, in many of the life situations that we are faced with, a lot of those things we learned by trying to come up or trying to derive patterns. If we are able to come up with patterns here, more or less we'll be able to find a generalization, and maybe that pattern is something that we can use to be able to solve this problem itself. So, what we're going to do is to try to find a pattern on this one. And most of the time, when you want to work for these patterns, what you can do is to try to work with a simpler solution, something that's similar to this, but something that would involve smaller numbers. Because if you try to simplify this by working with smaller numbers, then chances are you'll be able to see the pattern a lot clearer. Okay? So why don't we try to look for the patterns here by working with smaller numbers? We just have to make sure we keep the pattern of the numbers here. And if you look at the pattern of the numbers here, what can you say about 48, 49, 50, 51? Just unmute yourself. What can you say about these numbers?
They are all ascending by 1.
Yes, okay? These are consecutive numbers, starting with 48. So let's keep that pattern, but this time let's work with smaller numbers. Let's have the first smallest consecutive numbers. So why don't we do 1 times 2 times 3 times 4, and then plus 1, and finally take the square root of this. People, let's have Reese instead. Reese, can you please unmute yourself and help me out here? What's 1 times 2 times 3 times 4 plus 1?
25.
25, take the square root of 25.
5 here.
It is equal to 5. Okay? So, with this example, one of the things that you should ask yourself is that if you know these numbers here, these 4 numbers, okay, how would you actually get to the answer of 5? Now, keep that in mind first. If you'd like to establish patterns, you should be able to develop at least 3 of this kind, 3 of these similar problems, before you can actually find a pattern. Okay? So, let's try working with the next smallest consecutive numbers. And that would give us 2 times 3 times 4 times 5 plus 1, and then take the square root of this one. Okay? Sophia, can you help me out here? What's 2 times 3 times 4? Sophia, please unmute.
120 plus
Okay,
1.
2 times 3 is 6 times 4 is 24 times 5 is 120 plus 1 will give you 121. Square root of 121, Sophia, is
11.
11. And then again, same question you ask yourself. If I know these numbers, how would I get to 11? Okay, you already see a pattern? Why don't we have the third one? Let's work with the next smallest consecutive numbers. 3 times 4 times 5 times 6 plus 1. Take the square root. 3 times 4 is 12. 5 times 6 is 30. So I need to do 12 times 30, which is 360 plus 1. 361, and what's the square root of 361? Anyone? 361 is a perfect square number. What's going to be its square root?
Square root is 90.
Yes, the square root is 90. And then again, revisit your original question. If you know these four numbers here, how will you get to 19? If we look at the first example, here's our first example. If I know the first numbers, if I know any of these numbers, 1, 2, 3, 4, how would I be able to end up with 5? Try to find a pattern, or try to find a way to associate the numbers 1, 2, 3, 4, or any of those numbers with a number 5. Does anyone see a pattern here? Let's see, Reese, do you have any idea or any conjecture here? Do you have any hunch? Andre, can you admit yourself? It's on here. You can just admit yourself. Carlo?
Okay, so for the third one only, I added all the numbers 3 plus 4 plus 5 plus 6. And so that is 18. And then there's a plus 1 at the end. So I think it's
Okay, so you try manipulating those numbers by adding all the four consecutive numbers and then add 1. Now you have to check if that is something that applies to the first and second examples. If that doesn't apply, then you have to try to find another way of finding a pattern. Is there anyone who would like to speak out?
wait, sir, I found another one.
Okay, Carlo, go ahead.
Oh, sorry. Okay. So the first number and the
The
last
first example, okay,
the first for all the examples.
okay.
The first multiple and the last multiple, let's say your number one is 1 and 4. You
We're
multiply
talking about this one and this 4 here,
yeah,
okay?
you multiply them, which is 4, and then you add 1 at the end, which is 5.
That will get you to 5.
Yeah.
Is that something that's also applicable to the second example?
Yeah.
Take a look at the first number here too. The last number here is 5. Carlos can multiply them. 2 times 5 would get you 10. And then add 1, that seems to get you to 11. And it seems that that pattern would work. Let's try to confirm it if it's going to work in the third example as well. So get the first number, which is 3. Get the fourth number, which is 6. 3 times 6 is 18. And then add 1, that's correct. It would get you to 19. And that's a very good pattern. It seems that it's going to work with all of these smaller numbers. With that one, we can actually try to come up with a generalization that that pattern is also going to work to solve our original problem, which is 48 times 49 times 50 times 51 plus 1, and then get the square root. In fact, that is a correct pattern. So you see, if I ask you to do things now, if I ask you to solve things, there goes Aldrich's answer. So it's going to be 2,449. And all I have to do really is to multiply the first number, which is 48, with 51. So I'm going to end up with 48 times 51, which is 8. 4. 5 times 8 is 40. 5 times 4 is 20, plus the 4 carry, 24. I add things, 2, 4, 4, 8. 9 plus 1. There goes the final answer of 2449. In fact, if you don't believe me, you can try to use a calculator this time. Let me find my calculator. Okay. And let's see, what's 48 times 49 times 50 times 51 plus 1. And I take the square root of that one. This is the bottom, take the square root. There goes the final answer of 2,440. Okay? And that is one of the things that I wanted actually to draw out in every one of you. I wasn't expecting you to show me your prowess in computational skills, but actually I wanted to be able to see how you're going to approach this problem, given that it is a weird problem, it seems to be a difficult problem. So here you would see that in a problem-solving situation, you're actually asked to draw out the creativity in your solution. And one of the things that would allow you to draw creativity in your solution is to try to find patterns. When you look for patterns, one of the things that you can do is try working with smaller numbers so that you'll be able to easily, it's going to be easier to find the pattern. In fact, there are other patterns that you can work out here. It's not just multiply the first term and the last term and then add one. Try to find out. There's actually another pattern here. And if you can focus yourselves on the second number and the third number, how do you think by knowing the second or third number, you will be able to get the final answer? Anyone? Just unmute yourself.
Sir, for the second and third number of each set, you just have to multiply them, then minus 1. It will lead to the same.
Yes, that's correct. That's another pattern that we can get here. If on the first example, we simply multiply 2 and 3, that will give us 6 minus 1. That will give us the final answer of 5. And that pattern would hold true for the rest of the examples here. And so, with that pattern, we can then make a generalization that it's something that can work with the original difficult problem. So, which means all we have to do is to multiply 49 and 50. And that's something that's going to be easier because when you do 49 times 50, you're actually just multiplying by a number that ends with 0. So that's going to be a lot easier. So 0, 5 times 9 is 45. 4, 5 times 4 is 20, 34. And then like our pattern, we do a minus 1, we end up with 2,440. Exactly the same answer as we originally had. Okay? And I hope this is something that you're going to use all throughout your journey as a student, as lovers of math. You see, when faced with something that's difficult, do not fret out and do not just simply surrender. Most of the time, everything is about patterns. If you try to analyze your life up to this point, a lot of the things that you learned so far was actually developed through patterns. And at the same time, if we try to look at, for example, the coronavirus problem that we have right now, it's something that we also don't know. It's something which involves a complex problem. No one has ever encountered such thing as the coronavirus as the COVID-19. But then, how do we try to find solution to this seemingly complex problem? Well, there are many solutions. Others think that the solution would involve a military solution. So some people will think that for as long as you point a gun at everyone and tell them to make sure that they observe their quarantine protocol, that will solve the COVID-19 problem. Some people would rely on something that's mystical or magical. Former President Donald Trump, for example, claimed that we would be able to find a solution to COVID-19 because it would simply magically disappear. Now, of course, a lot of people would agree that the solution to the COVID-19 problem is something that involves science. So it's going to be a medical solution. I, on the other hand, aside from believing that this is going to be a medical solution, I think that first and foremost, the COVID-19 problem is something that we have to make use of a mathematical solution. And we have seen how this one is true. Okay? How do we learn all about the COVID-19 that we have learned so far? It's actually by making patterns. By trying to observe on how the virus spreads itself, we are able to gain knowledge of what the COVID virus is all about. By trying to come up with patterns on how to come up with a potable and most efficient vaccine, we are then able to slowly solve the COVID-19 problem. So you see, problem solving by doing patterns, by finding patterns, it's not something that we would just simply use on solving math problems or solving number problems in math, but rather it is something that's actually applicable to the real life situation. I would just like to make the conclusion that I hope with this problem, you get to realize how powerful pattern making is. And with that one, okay, the beauty of mathematics, that math by pattern making is not something that we would just use to solve problems in math, but it's also something that we can use to solve real life situations. And there goes the beauty of math. And I hope you try to, or I hope you are able to love math more, that you are able to appreciate math even. Finally, okay, I'd just like to hear one or two of you, okay, to answer this reflection. Now that I have shown you how powerful pattern making is in math and in real life solution, is that something you agree with? Do you agree that pattern making is a powerful mathematical tool in solving real life problems? In what way has pattern making helped you solve a real life situation? Okay. Anyone would like to do a reflection on this question? EJ, would you like to make a reflection on this one? Do you agree that pattern making is a powerful mathematical tool in solving real life problems?
Yeah.
Okay. In what way? In what simple way? Maybe in just your daily routines in life. Okay. In what way has pattern making helped you solve a real life situation?
The pattern on how I do my whole day. For example, like the time when I should be able to do this and that.
That's correct. Okay. And even more so, in today's OBL setup, a lot of people fall into the trap of procrastinating their work. They try to delay their work. And just like what you have said, that you have to have a certain time for doing things. If you don't observe that pattern, you will find out later. If you keep on delaying your work, you will find out sooner or later that you will be overwhelmed with so much work. And that would allow you to realize that you shouldn't be procrastinating your work. By working on those patterns, by seeing the pattern, that if you procrastinate, you will then be stressed later on because you will be overwhelmed with so much work. It would allow you to realize how you're supposed to do things a lot better next time. Right? Thank you so much for that, EJ. That's very good. Okay? And it's actually one of the things I would like to stress to all of you. Okay? Are there any questions, everyone? Okay, so thank you everyone. That ends our discussion for today. I hope that with that simple problem that I showed you, you will be able to like math even more. So thank you everyone. Say thank you and good night.